Hi everyone, what's up? Today I want to show you how you can solve this integral right here, okay? We're going to do this practice problem, and the technique that we're going to use is going to be u-substitution, okay? I think it's a pretty cool technique, and I think it's worth practicing a little bit, with this technique, okay? So yeah, let's begin. So now the first thing that I want to do is, well, I want to rewrite this integral so that this radical, I can write it in exponent notation, okay? So we know this integral is going to be the same as the integral of 4x, 4x is just going to be 4x times 5x squared minus 1, and you know that this radical, you can rewrite it as 1 over 3 as an exponent, okay? And this times the differential of x, okay? So now this is the new integral that we have. Since we're going to use u-substitution, remember we're going to choose the hardest looking expression that we can find. And I think that would be the 5x squared minus 1, okay? I think that would be a really good candidate to be u. So let's see what we can do. So u is going to be equal to 5x squared minus 1. The differential of u is going to be du times u prime. Now we know u prime is going to be 10x minus 1 is derivative, it's equal to 0, so there's nothing there, times dx, okay? So this is going to be the differential of u. So now let's see what we could do. I think now you can see something great, and that is if you divide both sides of this equation by 10x, you're gonna get a fraction that allows you to cancel out this x with an x in the denominator, and then you just get an expression in terms of u. Okay. So let me show you what I'm saying right now. So you can rewrite this integral as the integral. Now 4x, we're gonna leave it the same. So this is gonna be 4x times u to the 1/3. Now dx, we need to replace it, and based on our differential, based on the differential of u, we can say that dx is going to be equal to the differential of u divided by 10x. Okay. So now we can plug this value for dx. Now we're going to have a coefficient of 1 over 10. You can actually write it outside the integral, but well, I'm not going to do that since I didn't really leave much space. So we know dx is going to be du divided by 10x, okay? And now you can see that this is really nice because these two x's, they're going to cancel out, and you're going to get the following integral. So don't forget the equal sign. So now the integral that we're going to get is the following. This is going to be 4 over 10, which you can write it outside the integral, but I just wrote it inside, so it doesn't matter. You're going to get 4 over 10 times u to the 1/3, okay? du, okay? And now this integral, it's pretty easy to solve. We just simply need to use the power rule, okay? So this is going to be 2 over 5 times u. Now we need to do 1 over 3 plus 1 over 3 plus 3 over 3. That is going to be 4 over 3. And we also need to divide by that. So it's going to be 4 over 3 divided by 4 over 3, okay? Now this is going to be the same as if we had 2 over 5. We just simply now need to, do the arithmetic. So this is going to be 3 over 4 times u to the 4/3 to the 4 over 3, and of course I missed here the plus c. You can't forget the plus c. It's it's a very bad habit to just write the algebra and forget about the constant. You can't forget about the constant. So plus c there, don't forget about it. And this is gonna be plus c, of course. And you can just simply now multiply these two coefficients, and you're gonna see that you get 6 over 20, which is the same as 3 over 10. Okay, 3 over 10, and we know u is equal to this binomial in here. So that is going to be the same as 5x squared minus 1 to the 4 over 3. Okay, that's a 4. Nice. And of course, plus c. So this is going to be our final result. You can prove it by moving these 4/3 to the, by just differentiating. So if you move these 4/3 to the front, you would get 4 over 10. So this would be 4 over 10. The 3's, they get cancelled out. And you get times 5x squared minus 1 times the derivative of whatever is on of the inside function. And that is going to be times 10x, okay? Now you can see that these 10's, they get cancelled out. And you get 4x times 5x squared minus 1. And now let's see what happens with the exponents. So this is going to be the factors, and yeah, I missed the coefficient there, the exponent there. But well, it doesn't really matter. Of course it matters, but if if you're just writing the factors, you can see that it all works out, because when you subtract 4 over 3, when you subtract from 4 over 3, 3 over 3, well, you're going to get 1/3. So this is going to be 1/3. And that 1/3 just travels here. So, yeah, okay. That's I think, some people, yeah, I would say that's a good habit. Some people might think that it's not, but something you can do if you're in an exam and you really want to check real quick if your solution is right. Don't really, care about the coefficients, of course. Don't forget about the coefficients, the exponents, I'm sorry. Don't forget about the exponents, but, well, don't pay too much attention to them, as long as you can see what's going on in your head. Sometimes you don't really have to write them. You can just simply imagine, well, if I move these to the front, the 3's, they cancel out, and you get 2 over 5. And then, of course, you're going to get the derivative of 5x squared, and you can just simply write the factors. Yeah, I think it could be a good habit to kind of, just forget about the exponents for a moment if you're checking your solution and you're in an exam and, you don't have much time. That could be a good tip, okay? Just, a shortcut. So, yeah, that's been the entire thing. You can see that we go back to the initial function that we have, okay, which is what we expected. So yeah, that's been the entire video. I hope that you enjoyed it, you learned something. It is a very important thing to practice, solving integrals with u-substitution. So yep, I hope that this video has been valuable. And yep, see you in the following one. Bye.